So we're back, and I have gone back through and rescanned several pieces of the skull that had obvious bad holes in it. Some of the stuff that's left over, I'm not going to bother to try and clean up because it's going to come out naturally in the rest of the process. But I've tried to get the inside of the orbital sockets, the back side of the skull that I know is missing, and a few different things. I've also run the global registration again because I've introduced some new data. But although I'm rerunning it again, I didn't have to do it throughout the entire scan. I only did it for the new material and enough of the old material that I would have something to work with. I didn't bother re-registrating well over half of the original scans. But I'm going through the same process because I'm adding new data, so it's new raw data and it's got new garbage in it. I have to go through the alignment process, the cleaning up process, the global registration process, and now I'm removing the outliers, and you can see it's going much faster this time. Of course, as soon as I said, see, it's going faster, it slows down. Oh, it's almost done. And there is the scan. Globally registered, outliers removed, everything nice and lined up. There's the full data set, still a point cloud. We are now ready to start fusing our mesh together and seeing how that looks. So under the fusion panel, we have the outlier removal, fast fusion, smooth fusion, and sharp fusion. Now fast fusion would be good if I just wanted to check it to see what kind of errors and holes I have in it. Smooth fusion loses a lot of the details. It's also a faster process, and it comes out. It's really if you want to use that for things that you know are smooth, that because of the nature of the texture of the surface, the scanner may have introduced some artifacts that are too significant for it to programmatically weed out. So you could use smooth fusion for that. A sharp fusion is what we're looking for because we want to see all the details. And if I expand the sharp fusion options, I have a resolution option here, which is set at 0.1. This number is in millimeters, and it's the average size of a polygon that I'm going to generate across this surface. Every tenth of a millimeter, it's going to put another polygon. Now, this is a lot of surface area, so there's a lot of millimeters on that, so that's going to be a lot of polygons. 0.1 is about the point of diminished returns, gives you the highest mesh definition. I can go lower than that. I could go 0.05, and that will get me a tremendously huge mesh, but it won't really give me a much more detailed mesh than, say, 0.1 would. The other option that I have here is watertight. Watertight means it's going to go through and it's going to fill in all the holes that it finds in the mesh. So any hole that it finds in the mesh, it'll fill that over with smoothed out data. If you have any significant holes and you have watertight set, you'll see sort of a blistered look, and it really will look like a blister, just a smooth little round cap over any voids that might be in there. But we're just going to go by radius, so it's going to fill in holes that are 5 millimeters or smaller. If it's bigger than 5 millimeters, it's going to leave it as a hole, and that's kind of what we want. I don't want to make this watertight yet because I know I'm going to be bringing in the deer antlers. And so I'm also not really too concerned about any holes that may remain in this mesh because I'll have a chance to hit them one more time when I bring in the antlers. This is going to be a long process. So this will be the last time I speak to you for a while after I hit this button right here. All right, so the fusion is complete. Our first level of sharp fusion. It made one mesh that's 665 gigabytes in size, and if I go down and look at the project info, I see that it is 26,709,415 faces. But who's counting? And we can see that it left a lot of holes in the mesh, which we sort of anticipated. I knew that there would be missing data from around the sinus cavity because there's no way the scanner is getting down in there. When we do the finished model, we'll just let it fill that in with whatever it wants to make it watertight. But there's still some missing data around the front part of the nose that we could get. There's some holes around the teeth that we could get. So we're not quite done with this scan. I will go back and take some more scans of it and fill in those holes before I do the finished mesh. But I want to take this opportunity to kind of demonstrate what the rest of the process would be, assuming that I didn't have to go back and do some more work on this. Once I get my sharp fusion, as I said earlier, this has got a polygon every 1/10 of a millimeter. So it's a lot of polygons. The next thing we're going to do is down here in the post-processing tab, post-processing, wow, that's a word. I'm going to do a mesh simplification. Now what this does, this is going to go through the mesh and it's going to look for flat areas or smooth areas and take all the extraneous polygons out of the flat areas, but leave all the polygons in for the details. So we actually shouldn't see a whole lot of change visibly in our mesh, but the polygon count should go down dramatically. Of course, on a model this big, it is another involved process. So we'll just have to be patient and wait. Well, I will. You won't have to, because you will be right back.